Hi, very good morning to you, evening or afternoon depending on where you are at the time you're watching this video. I'd like to thank our new subscribers for tuning in. We've added another 8,000 I think in the last month or so, so you're very welcome to come here. What we try and do here is present a lot of information for people, and we can give you the information based on logic and facts and evidence, but we can't make you do anything with that. It's entirely up to you what you choose to do with that. But I will say this, is that we are heading into some very difficult times. All of the evidence points to that. And when anything is based on weather and climate, it's never very easy to establish facts out of that because of all the variable things that are a part of climate. For instance, like what we're looking at now, this diagram showing us the changes in obliquity or the Earth's natural tilt. When you want to work out, well, how much is it then that we're further away from the sun in the northern hemisphere during winter, you can do those calculations and get almost very accurate accounts. So it's roughly about 1,000 miles further away from the sun than when we are in the summer over the northern hemisphere. That's when the tilt on our orbit around our sun is closest to the sun, and during the winter, as you know, we are further away from the sun, so the tilt puts us further away, at least another 1,000 miles away, and that's why we get our winters and summers. It's pretty basic knowledge, that is. But when you start adding into account the grand solar minimum, how that affects climate by altering the jet streams via the route of more cosmic rays in the upper atmosphere, and then adding to that the changes that are naturally going to take place during a magnetic reversal, and then you add into the fact that we are travelling further away from the sun at the negative end of this Milankovitch cycle, which we'll look at in a minute. All these things are variables that are very difficult to put into place, especially when you account for then jet streams, pressure, precipitation, direction of wind. All those things make it very difficult, even in this modern society, to predict what is going to happen next with the weather, because all those variables change. But if we just look at some of the variables that we know and we've got facts on, we can make some predictions as to what is going to be the likelihood for people living over the northern hemisphere, people living over the southern hemisphere. And that's what we're going to do in this video. And we're going to show you why we are saying to people, you are not in a very good position if you live over 40 degrees latitude on the northern hemisphere, and likewise on the southern hemisphere. It will be no different for those people, because as you know, naturally every year we enter a winter and a summer, but something is changing. Not only are we seeing more dramatic changes in our climate, at least since the 1990s, when coincidentally there was a great uptick in the speed, which meant that the magnetic North Pole was migrating further over the northern hemisphere at any point in the previous history down to the 1900s, and it was covering more distance in a shorter space of time. And of course, since that space of time, since the 1990s, the weather on this planet has become more dramatic, and that is because of the breakdown of the jet streams. We should have over the northern hemisphere nice polar jet streams, and in the subtropical regions we should have nice subtropical jet streams. But what we've got today is a breakdown of this, and we're getting mixing, which we're going to look at a bit later on in this video. But I just want to cover a few basic facts. So the Earth's tilt is what keeps the northern hemisphere in the winter and allows the Arctic to regain ice usually. But this is one of the regions on our planet, or one of the two regions on our planet, so we've got the Arctic and the Antarctic, that hold ice all year round. Why is that? It's probably because of the tilt. allowing that to go into a cold region for 6 months of the year and then go into a warm region. But in that cold region of where it's been 1,000 miles further away from the sun, it's allowed it to build up a certain amount of ice. And they're all very small amounts, so it's just a marginal increase every year of a build-up, but it's enough not for it to go too warm that it melts it all. Now, when you add into the fact that not only do we have seasonal changes every 12 months, but we also have larger changes, which we're going to look at now, over 100,000 year cycles. We get interglacial and glacial periods, and we'll look at that now. So before we talk about percentages, how long it takes to reach maximum eccentricity, I just wanted to show you the cycle. It's an exaggerated animation, but it gives you an idea of what is happening during these 100,000 year cycles. The Earth moves out slightly more on its orbit around the Sun. During it takes 50,000 years to go out and 50,000 years to come back to a natural cycle. It's when it's at its more spherical shape that we're in an interglacial period, and when it's at its more elliptical shape, it's in the deepest part of the glacial period, and it takes 50,000 years to go out and 50,000 years to come back. But what is that in terms of miles then, with regards to our planet? Let's look into that. So I've took a screenshot and I've just added on there the amount of time in years it takes to go to its maximum elliptical shape. So you can see clearly 50,000 years one direction, and then it takes 50,000 years to go back. That makes up the 100,000 year cycle. That puts us in a glacial and in interglacial temperature. So what is that then in years, you might ask yourself? So it's around 1,000 miles in total. So 50,000 years we will go to the maximum elliptical shape, and then 50,000 years will go back. So the distance at its furthest is 1,000 miles. Now, at the beginning of this video, I showed you the Earth's tilt and how that changes the climate over the northern hemisphere during the winter and the southern hemisphere during the summer. Now, if we're 1,000 miles away, and naturally, with the angle of tilt of our Earth at maximum elliptical on this chart that we're looking at, we will therefore be 2,000 miles away. And when we are at that distance away from our sun, it will be like the northern hemisphere constantly, and that's what puts us in a glacial period. So, you know, from now on, for the next say 40,000 years, we will be getting colder and colder and colder, and that is exactly what we're seeing every year. And that's why we have started already to see, I believe, a rebound in the glacial ice reforming. So the Arctic is, you know, rebounding now as we move further and further out on our elliptical orbit. It's around 1,000 years per 20 miles, and we're already 6,000 years into this. So 6 times 20 gives us 120 miles. So we've already moved in that 1,000 mile towards that 1,000 mile peak, which is puts us in the deepest part of the glacial period. We've moved 120 miles already in 6,000 years that we're already into that cycle. So, you know, that's around about 12% in. You know, I wish we was on the returning side and we was 80% leaving the glacial period, because we could all be looking forward to, you know, a warmer climate, but that's not going to happen for at least another 90,000 years. But from now on till then, you know, we are starting to go colder and colder and colder, and we are not geared up for this, guys. You know that. Our northern hemisphere, which I'm going to show you in a minute, are these countries that are going to be affected permanently from now till the return of an, you know, interglacial period, will probably be uninhabitable. And you're probably going to be shocked at the end of this video to see probably your own country being included in that region. And this is what we're saying. Yes, it might be thousands of years away before we reach, you know, equilibrium, where we're at maximum 50,000 years out. But that doesn't mean that this Earth can cool down a lot quicker with the added effects of grand solar minimum and a magnetic reversal. So bear that in mind. What we're doing is just providing the facts based on logic and the evidence that we've gathered today to give you a clearer understanding of what you and your loved ones are facing. So this is what our Earth looks like today. 12% into the Milankovitch cycle, which is what makes us travel that further bit away from our sun every year. In total is 1,000 miles at maximum. And this is what our planet looks like today over the northern hemisphere. I'm just going to rotate it a little bit slowly so that you can see where you live if you're over the northern hemisphere, when your continent is 1,000 miles further away from the sun. You can see all the regions in the blue, the jade, green and the purple are all sub-zero temperatures. So mostly below 0 degrees Celsius. And obviously, as you would expect over the southern hemisphere, if we just tilt that, you would expect that region to be a lot smaller. And this is just 1,000 miles closer to the sun than it is usual. But what I will say is, even though it is 1,000 miles closer, there is still sub-zero temperatures on the Antarctic region. That is standard. So even when the northern hemisphere of our planet is in its closest angle to the sun in the summer, there will still be ice in the Arctic Circle. That's standard. But when our planet moves out into the Milankovitch cycle, or the orbit of maximum distance, our Earth will not only be 1,000 miles further away, but during the winter, because of the tilt, it will put it even 1,000 miles further away, and that is what puts our planet back into a full-on glacial period. That's what we are 12% into right now. So that gives you an idea of what to expect. That is what's coming, and we can't effort accurately what effects the grand solar minimum will have on speeding that up, or what effects the magnetic reversal will have on speeding that up. But what we do know is, within the last 40 years, the climatic effects as a result of the magnetic pole reversing have dramatically changed significantly, and it has altered the jet streams, which delivers Arctic temperatures at lower latitudes, and that's because of the fragmentation of the jet streams. I'll just give you a quick look of what the jet streams look like. So as you can see, what I'm talking about, where we have subtropical jet streams flowing straight up into the polar jet streams. Generally the subtropical jet stream should be around about 60 degrees latitude, and it should be the polar jet stream should be around about 30 degrees latitude over the northern and southern hemispheres. But in both cases, when we look at it today, we can see that the polar jet stream is reaching straight down into them subtropical regions, and of course this is what sets up these unpredictable weather anomalies, where you get flash floods in less than 12 hours notice, because of the unpredictability of them. It's not just over the northern hemisphere, it is also over the southern hemisphere. If I give you a bird's eye view of what they look like, starting with the Antarctic, you can see there is no distinction between the polar jet stream or subtropical, and that is the same case for the northern hemisphere over the Arctic Circle. You can see the dislocation of the polar jet stream straight there, feeding down into the tropical jet stream. So based on all the evidence that we've gathered to date, and what we see happening just on a regular 12-month cycle, where we go in the northern hemisphere into winter and then 6 months later we're in the summer. Just based on what we know with these facts, we can say that as we are only 12% into the Milankovitch cycle, and we've for that reason travelled out of those 1,000 miles that we move further away in a 50,000 year cycle, we have travelled already 120 miles. That's 12%. But we know that when we're at maximum elliptical orbit, we will be at 100%. And as we go further and further away now towards that maximum of 50,000 years, we will see this Earth move at least 1,000 miles further away from the Sun. And then during the winter time, it will be 1,000 further miles away from the Sun. So that puts it at 2,000 miles away from the Sun in the winter months. And that is for that reason that all these regions that we're looking at today on this map, if you live in one of these regions, or you're above 40 degrees latitude on this planet in the northern hemisphere and in the southern hemisphere, it will be an uninhabitable place to live. Now you might think we've got plenty of time, but I did say that was if we was just looking at the Milankovitch cycle, which we know we are 120 miles further away from our Sun than what we was 6,000 years ago. We have other anomalies that are occurring right now, which I believe will accelerate this greatly. If anything to go on over the last 40 years of looking at the climate and the changes of the climate of the planet, we are probably going to see this accelerate a lot quicker. And what I'm saying to people that live in these regions, what we're looking at today, where the temperature is in the blue, the jade and the purple, which is at some extremes minus 40 degrees like in Canada, these places are going to go offline. There will be no crop production in these regions. There will be no cities that survive this in these regions, and in most cases they will be buried under 1,000 feet of ice. And that is why I say, it is time to start thinking about this seriously. And I know that it doesn't matter. For some people we give this information to, and they know and understand it and they take it seriously, but they still don't act. That's why I say I can provide the information for you. I cannot make you act on that information. There's a saying, isn't there? You can lead a horse to water, but you can't make it drink. There is a lot of people that will stare at a train approaching them, but they won't get out of its path. And we're just looking over, America, Canada right now, and then we're going to have a look over Europe, and you can see what is going to be affected in Europe. And if you think the UK is a safe place to be, it isn't, because once Canada has dissipated in its magnetic intensity, it will mean that we are no longer protected where we are in the UK. And if you look at where the last glacial till was deposited after the last glacial period, it was central England. So most of central England will look like these colder regions in Europe, and anywhere in Europe, and you can imagine the amount of people that live in these places are going to be unable to have a normal day because of the sub-zero temperatures that will be present there, not just in the winter months, but all year round and for thousands of years to come. Now you can understand, can't you now, why your governments aren't telling you this? Because if they did, can you imagine how many people would, if they was prepared to act on the information, they would move instantly. All the properties in these regions that we're looking at in the blue, the jade and the purple are worthless. They're not going to be worth nothing, because if you can't sustain a living in these regions, then you will do exactly what the Mayans done when they could no longer stand the drought seasons. They had to migrate. That's why they left their cities. That was just, the Mayans. We have seen migrations, over thousands of years of our history. where we have had to leave the cities that we've built and move into, different regions of this planet. We've made some real bad mistakes for ourselves, by incorporating borders, because it's going to stop the migration of a lot of people when they realise, that they have got no choice but to leave the cities. As well as I know, our cities are not geared up for this temperature. And in any case, most of these cities and buildings will be buried under thousands of feet of ice and snow. There will be no agricultural productive land in these regions that you're looking at right now. It will game over, like I say, for anywhere over altitude on the northern hemisphere, and the same for the southern hemisphere. We cannot avoid this. There is nothing any government in the world can do about this. It can just ride it out until there is no more time left. And then we are going to start to see mass evacuations of these countries and these states. There is no doubt whatsoever that this is going to happen. You know that now. 100% this is going to happen. There is nothing humans can do about it. We have to learn, as we have done, and we are very capable of doing that, to adapt to the new environment as it changes, as we have done for thousands of years, guys. It's simple as that. But what worries me is that we have become a different human being. Like I said, in November I went down fishing on Chisel Beach here in the UK, and it was freezing cold, and we're just not hardened like our ancestors was to living in these conditions. You try living or sleeping just one night on a hard floor, or good practice now, go do a couple of days camping if you're over in the northern hemisphere, and see how you get on with that, how uncomfortable that is. That's why I say, the best thing to do is either migrate south to the equatorial region, but even at the maximum, you will be still 1,000 miles away from the sun in 50,000 years' time. And, even at the equatorial regions, like the mines discovered, it was uninhabitable because they didn't have regular rainfall. So they had to leave their cities that they had created. It's just what we're going to do, only on a grand scale. Our technology is not going to help us. Our governments haven't geared up for even the beginnings of this. They've not buried all the power cables under the ground, so when they start to build up ice, the cables will snap. It will render cities without electricity. That will shut down the sewerage, the logistics eventually, and there will be no choice but to see millions and millions of people starve as a result. That's why I say two choices: migrate south. You're not going to be on your own. There are going to be millions and millions of people heading in that direction at that point in time, or learn to adapt to the new climate like the Eskimos do, which is not easy because they put up with one of the most extreme conditions on this planet, and it takes generations of knowledge to know how to do that. And there is still time for a lot of us to learn to live like that. I mean, in Canada, a lot of people do put up with these sub-zero temperatures, but we're seeing other things affect, the ability for people to do that. Guys, this information has been brought to you by just a few people that choose to chip in a little bit of cash. If I can encourage a few others to do that, we can keep monitoring, some of these anomalies. And, if ever we do get more information based on more sensors out there that we put out in the field, we can give you a more accurate timeline as to what to expect with this coming magnetic pole shift. At least that we can keep our eye on the climate, and how that changes as we go further into this Milankovitch cycle as well. And we can monitor the active production of sunspots as well, because all these things play a part in the climate on our Earth. And you know, if you want to help support what we do, there's a link down there in the description. Meanwhile, take care of your loved ones, and I'll say what I usually do, as always. Bye for now.